Welcome to Impact Phase. Let's just go to question 12BII. It reads, the diagram above illustrates energy levels in the hydrogen atom. E0 is the energy of the ground state. When an electron makes a transition from level n equal to 3 to level n equal to 1, it emits a photon of wavelength 1.02 times 10 raised to the power of negative 7 meters. Calculate E0, then I calculate the ionization potential of the hydrogen atom. So we are going to start calculating immediately. The first thing is for us to calculate what? E0. I want to keep this book. Okay, so how do we calculate E0? First of all, the transition. Energy distance, these energy levels are fixed distances you can find electrons. So we are going to study that on this energy word quantization. So in case you have not studied energy quantization, please do well to comment below. Definitely, maybe we can arrange a lesson for it. So let's carry on. So the transition is from here to here. So whenever there is a jump, energy will be emitted in form of light. So the energy emitted E will be equal to this here now. The energy of this level, let's call it E for 3 minus the energy of this one, since we already have E0 here. So let's just use E0 so that we wouldn't get confused. And this will give you what? That's what we're looking for. So this will give you what? The E3 is already giving us negative 1.50 minus what's your E0? E0 is not given. That's what we are looking for. We are asked to find E0. That is the energy of the ground state. But E, according to Max Planck, is given as hc over what? Lambda. And this is equal to minus 1.50 minus E0. So now this can be sorted out. So this will just be h is actually, look at it here, the constant 6.6 times 10 raised to the power of negative 1, 34, times the speed of light is 3 times 10 raised to the power of 8. Then divided by what's lambda? Lambda is 1.0 2 times 10 raised to the power of negative 7. And this will give you negative 1.50 minus what? E0. Now, if you do this, you're going to get 1.94 times 10 raised to the power of negative 18 is equal to negative 1.50 minus E0. So if you convert this to electron volt by dividing it by 1.6 times 10 raised to the power of negative 19, if you divide this value by 1.6 times, you're going to get 12.13 volt is equal to negative 1.5 negative E0. So what will E0 be? E0 will just be equal to minus or negative 12.13 E volt, and then negative again. What do we have? Here will be, here coming here will be positive. So the negative will just multiply through, then we're going to have negative 1.5 E volt. This will give you about negative 13 E volt. This will be the energy of the ground state. That's the first. Then ionization energy. Let's just do that right away. The ionization energy. Ionization energy. Then I wrote it down somewhere. Potential. Sorry, potential. What will it be? Potential. This will just be equal to E infinity. Let me write it well. E infinity minus what? E0. And that would be very simple. What's E infinity? E infinity is 0 minus in bracket. What's your E0? Minus 13 point. That's supposed to be 13.6. I think I made a mistake here. 0.6 E volt. So minus 13.6 electron volt, I mean to say. So this will just give me 13.6 electron volt. So the ionization potential of hydrogen atom will give you 13.6 electron volt. Ionization potential is the energy required to remove an electron completely from an atom, and that's what we calculated for what? The hydrogen atom. And the energy of the ground state E, we also calculated it to be what? 13 watts, negative 13 watt 0.6. This negative is because you have to do work to remove electron from that particular watt energy watt level. My name is Mr. Oprom Darlington. Mr. Oprom. So do well to subscribe on my YouTube channel, Darlington_physics. Thank you for watching.